So how might we go about trying to do this in a more sustainable way? How might we have a chemical industry that can be more sustainable and more bio-based? Well, a term you're hopefully familiar with and a concept that you're familiar with is that of biorefineries. So what we're doing in a biorefinery is we're taking a biomass, ideally a waste biomass, and then we're converting it into fuels and energy, much like we saw for the oil biorefinery. We'll probably generate some very interesting materials, but also we want to look about generating chemicals with which we can build up a bio-based chemical industry. And so these chemicals here, certainly those produced early on in our processing of biomass, these start to really look like our base chemicals, or the equivalent of our base chemicals. And already there's some good examples. We'll see a slide later about the sorts of products that have already been produced from biomass through these base chemicals. And so what we, much like we saw for the oil refinery, again we can see that we do some processing and then we build up to some simple molecules through derivatives and through to an array of products. But what you probably also hopefully have noticed is that our feedstock is actually a little trickier than before. So we're already having to think about different component parts within the feedstock, and we'll take a closer look at this in a bit. But also our first set of building block molecules, there's already going to be many, many more. So these building block molecules we refer to as our platform molecules. So these are the first simple chemical structures that we would generate from the processing of biomass, and we would use these to build up our new bio-based chemical industry. But because we start with a feedstock with many more heteroatoms in than you have for fossil resources, we have far greater complexity, and so we have many more platform molecules than we do base chemicals. So this is a problem and an opportunity. It means that the chemical industry would really need to change its structure, how it operates, but it also means that maybe we can reach the functionalized products that we want in less chemical steps. So in a simple view, a platform molecule is a bio-derived chemical where we want all of its constituent elements to be derived wholly from biomass, and that it can be used as a building block for the production of other chemicals. And if we try to think about how this fits closer to our comparison with base chemicals, then we would probably also want our platform molecules to be something that's typically small, probably relatively simple, most likely ideally of a very low value, but also in very high production volumes. And this certainly causes some issues with what other people in the literature have referred to as platform molecules, and I maybe also probably push the boundaries of these comments in one of the examples I give. But certainly if we're trying to think about how we move from this oil refinery based chemical industry through to a biorefinery based chemical industry, then quantities, large volumes of some of these platform molecules is certainly going to be needed. For those of you who prefer a visual representation of this, then it's something along these lines. Hopefully this is quite simple to follow. So we just have our biomass feedstock. There are several valuable processing technologies that we apply to that biomass, where we'll generate a chemical compound, a simple building block, and then hopefully it has functionality on it and good examples of numerous derivatives it can go through. In terms of the processing technologies, the four main ones that you should be aware of. So to begin with, there's extraction, and we'll take a look at an example of one of these later. So this is where the chemical structure is inherently present within the biomass, and we use some extraction technology to remove it out of the biomass and use it in that form. Probably the best example of this currently that happens is for the pressing of oils and us using the triglycerides to support things like the production of surfactants, home and personal care products, biodiesel production even. Then you've got something like, then you've got chemical transformations, and these are often termed thermochemical. So chemical transformations is where we'll add some chemical agent into the system, into our biomass, and this causes some often causes some tricky issues in terms of this intention of a platform molecule being 100% wholly bio-derived, because sometimes our chemical agent actually could be fossil derived and can skew that terminology a bit. Thermal treatment is where we're using high temperatures, and it's often, as an example, something like fast pyrolysis. Again, there's some crossover with thermal and chemical, because some thermal processes involve things like the addition of an acid. And then the last major processing technologies for generating platform molecules are biological, so fermentation. So we're using bacteria or fungi, or maybe even enzymes as well fall into this, whereby we're converting biomass, normally under mild conditions and with high selectivity, but often needing a lot of assistance in terms of things like nutrients and pre-processing of the biomass.